reaction. And so we'll quickly go through some of these key concepts here. Okay, right. So starting with, chapter 1, the basics. Okay, so you should know the different stuff present in air. So air, is it a mixture, is it an element, or is it a compound? What is air? Is air a mixture, an element, or a compound? Air is a mixture, okay? So just like petroleum is a mixture, so petroleum is also a mixture. What is the similarity for both of these mixtures? Is that you can separate it into simply a substance by the method of fractional distillation. So both air and petroleum, they are mixtures that can be separated by fractional distillation. What is the physical property difference that fractional distillation is based on? What is the physical property difference? It's boiling point difference, right? Yeah, so we have different components.
We're doing revision, right?
Yes?
We're doing revision, right?
Yeah, we're doing revision.
Okay.
Yeah. Or if you suddenly remember something that you aren't too sure about, just raise it. Okay, just raise it. We'll go through the topic together. So air is a mixture that can be separated by fractional distillation. Yeah, and this method of separation is based on difference in boiling point. Okay, so based on difference in the physical property boiling point. So different things have different boiling point, so they will boil off at a different time when we do fractional distillation on air and petroleum. And can you tell me what are the four main gases present in air in decreasing order? Nitrogen. Oxygen. The third one is not carbon dioxide.
Carbon monoxide.
No,
we'll be
if the
dead.
third one is carbon dioxide, we'll all be dead. The third one is the noble gas. Argon. Finally, we have carbon dioxide. Okay, so and you will find that they do not add up to 100%, which is okay. Yeah, because the rest are just noble gases. Okay, so you can put down nitrogen, oxygen. Only the first two you need to know the rough percentages of. Okay, so the remaining two, because they still do not add up to 100%, you see. So this already make up 99%, these two gases. And then you have 0.9% of argon. So I'll put it in bracket because you don't really need to know the exact number. And then we have carbon dioxide, which is 0.04%, and it's rising due to human activities. Okay, so it is rising due to human activities. So that's the four gases. Okay, the remainder you can say noble gases. You won't find hydrogen. Okay, in the air because it's too light. It escapes Earth's gravity. Okay, so remainder other noble gases. So you see, argon is one of the most abundant noble gases already. And then we have some tests. So tests for a few gases. Okay, you can tell me what you know about these substances. So the test for oxygen, for hydrogen, for carbon dioxide, and for, not in this chapter though, but for sulfur dioxide. So how do we test for these 1, 2, 3, 4 gases? Yeah, oxygen will be for glowing splint, but for hydrogen, burning splint. Okay, so what will you hear or see? Okay, pop sound for hydrogen, so you can write down for oxygen we use glowing splint. It relights, yeah, or rekindles. Okay, so this is the positive test result. It relights the glowing splint. And for hydrogen, you use the burning splint, which is actually burning. You know the glowing splint, only the tip is burning. Okay, so you can get the glowing splint by extinguishing the burning splint. So that's the difference between them. And for burning splint, you will hear a loud pop sound, which is actually an explosion. Okay, the equation is H2 plus O2 forms H2O. So that you need to know. What about the test for carbon dioxide?
Lime water.
Yeah, and in exam, I really wanted to put down the starting and the finishing color, not just the finishing color. So it will go from colorless to milky. Okay, so colorless to milky. But for those of you who did this in biology, you may know that if you pass excess amount of carbon dioxide into the already milky line water, what will happen to it? It will turn colorless again. Do you know what is happening? Well, you have to write equation. So draw this diagram for me, please. Okay, so you have a clear line water. What is the chemical formula of line water?
CaOH2.
CaOH2, calcium hydroxide. Calcium hydroxide. So write down the formula of calcium hydroxide. So this is lime water, liquid. When you put a little bit of CO2, it will turn milky. That's because of the formation of a white solid, calcium carbonate. But if you pass excess amount of carbon dioxide into it, it will turn clear again. That's because it will form like a soluble salt, CaHCO3. So we can describe what is happening here using two equations. So you can write down equation 1. So CaOH2, AQ, write down the state symbol. So you know why you see change from colorless to milky. So it's from aqueous to a solid, to a white solid. This is why it turns from clear to milky. But why would it turn from milky back to colorless again? That's because when the calcium carbonate reacts further with additional carbon dioxide and water, it will form another soluble substance, which is a different soluble substance than before, you see. This was the starting clear substance, CaOH2. And this is the new clear substance. It's a different clear substance. Okay? They're both soluble though. So therefore, this is the equation for step 2 and equation for step 1. Okay?
Yeah.
Right. And then we have, just a very quick look at these concepts here. And how do we test for different natural ions?
What about SO2?
Right, for SO2. For SO2, you use an oxidizing agent. Okay, what is one oxidizing agent that you? KMNO4. What is the color?
Purple.
Purple. Yeah. So this is based on the fact that oxidizing agent reacts with reducing agent, just like an acid reacts with a base. So here you use KMNO4. So it will turn. You know, SO2 is a reducing agent, and KMNO4 is an oxidizing agent, which is purple in color. So when you react MnO4 minus with SO2, the SO2 will be oxidized because that's what MnO4 minus does. Okay, so it is an oxidizing agent, so it will oxidize the SO2. And at the same time, the MnO4 minus will be reduced. What is it reduced to? Mn2 plus. So what will you see?
Purple to colorless.
It will turn into a colorless solution. Okay, so therefore write down the positive test result. It will go from purple, which is what MnO4 minus is, to colorless. Okay, so it will go from purple to colorless. So that's how you test for SO2. Yeah, so these 4 gases are very important. Okay, O2, H2, SO2, CO2. And what about the test for water, chloride, and silver ion? So how do we test for, let me put this down in here. So test for metal ion, we use what we call flame test. Okay, so metal ion. So do you remember the flame color and how we do flame test? How do we do flame test? What do we use?
We use the platinum white.
Platinum white. Do you know why we use platinum white but not any other metal?
You react with.
It's not the reaction that is important. It's that other metals may give a flame color. So if you use the platinum white itself does not give off any flame color, which is important because you want to know the color due to the sample, right? Not due to your testing rod, right? So therefore, the first question they will ask you is why should PT wire be used? So why should platinum wire be used? That's because this metal, PT, okay, it doesn't give off any colored flame. Okay, so it does not produce a colored flame, which is important because any flame color you observe would indicate the presence of a particular metal ion. So if it is a self-colored, then it may mask the color of the metal ions that you are testing. So how do we conduct the test? So you can put down the procedure really quickly. Just draw a diagram. You must clean the platinum wire in what kind of solution? Hydrochloric acid. So we should first clean it because you don't know whether the student before you had cleaned it properly. So we clean it by dipping it into conic shell. We don't use distilled water because distilled water cannot remove metal ion as easily. Yeah, conic shell is for cleaning. So for cleaning, after the rod is cleaned, you can stick it into your sample with the metal ion. So this is the metal ion sample, and then you heat the wire with the sample in a, what kind of Bunsen flame do you use? Do you use the luminous one, which is the orange one, or do you use the non-luminous one, which is the blue one?
Non-luminous.
Non-luminous. Because if you use the orange one, it will just, mask any other color, okay? So you should use the non-luminous flame. So draw a Bunsen burner here, and use the non-luminous flame, and then you can observe the flame color. So the last step here is to heat the sample in a non-luminous flame. So they will ask you why shouldn't you use luminous flame. Okay, so right now luminous flame will mask. Okay, so luminous flame may mask the flame color. So may mask the flame color due to the metal ion. So now I'm going to put down a few metal ion. You tell me what their colors are. So starting with K plus, Ca2 plus, Na plus, Cu2 plus, and yeah, I think these are the most important. Okay, and then what is the color of K plus? Lilac. Okay, don't say purple, even though lilac is a shade of purple. Okay, just like lavender is a shade of purple. Okay, calcium. Red. Yes. Sodium. Golden yellow. And bluish green. Yes. So we have bluish, green, golden yellow. Okay. So we have these are different tests for metal ion. Then we have the test for the chloride ion. Okay. So for test for chloride ion, we use
Silver.
Yeah. So you have to say acidified. Silver nitrate. Yeah. Why must you acidify it? What happens if you do not acidify it? It will not work. It will simply, but you can't just put it that way. So you first have to say, if you have a sample without any chloride ion, it may still have carbon dioxide dissolved in it. When carbon dioxide in the air, so from the air, dissolve in water, it will form carbonate ion. And this is a very nasty ion because it will interfere with the test by reacting with silver ion to form a white precipitate. So this is a white precipitate that you were not expecting. You remember the test for chloride is relying on the formation of silver chloride, right? Not silver carbonate, right? So we don't want any carbonate to confuse us. We don't want to come to this conclusion that the white precipitate is silver carbonate. So what can we do? We can just add acid into it. So if you add acid into the sample, it will drive away all the carbonate as carbon dioxide. Why is that? That's because acid, which is represented by H plus ion, it can react with carbonate to form CO2 and H2O. So essentially, the carbonate ion that is in solution, after you add acid to it, they are forced out of the solution as a gas. So the CO2 becomes a gas and escapes. So what I will try to say here is that the carbonate ion will be gone when you put acid into it. So they will not be there to interfere with your test. Okay? So that if you now have a sample with chloride ion, which has also some carbon dioxide dissolved in it, you can add acid first. Okay? The acid that you should remember is CONHNO3. Okay, nitric acid. Okay, or just nitric acid. You don't have to mention the concentration here. Then the carbon dioxide will be gone. So the carbon dioxide will now leave again. Leaving behind just chloride. And then now you can add the silver nitrate. The silver nitrate can react with the chloride to form, what is the color of silver chloride? It's white. It's a white precipitate. So make sure you spell the word precipitate correctly. Okay. Because I see some students from Form 4 spelling it precipitate, okay, which is not true. So you have write down the two equations.
That's me. That's me.
Yeah, that is happening here. So 2H plus CO3 minus becomes CO2 and H2O. When asked what is the use of this reaction, well, you say this is to remove carbonate ion formed by CO2 dissolving
Dry.
in solution. What about on the right? What equation will you write for the reaction between silver ion and chloride? It will just be Ag plus Cl minus forming AgCl. Don't miss out the state symbol. So AQ, this is why they are soluble and colorless. You get a solid. So this is a white precipitate, exactly. Okay? Then we have the test for presence of water and the test for the purity of water. What is the difference between testing for the presence of water and testing for the purity of water? By presence, we mean I just want to check if there's water inside. I'm not checking if it's safe for drinking. Okay? Even muddy water can give us a positive test result for test for presence of water. So I want you to be very, very careful in the exam. When asked to test for water, you should ask another question first. Okay? Are you testing for the presence or are you testing for the purity of water? Because the answer is different. Okay? So test for presence of H2O. To test for the presence of H2O, we can use two chemicals that will show color change when water is present. What are they? Chlorine chloride and copper 2 sulfate. Remember these two chemicals. Okay, so use number one, and I think you forgot one very important word, is anhydrous. Okay, so anhydrous cobalt 2 chloride. Anyone can tell me the formula of cobalt 2 chloride? COCl2. So in the dry state, when it reacts with water, it will turn into a hydrated salt, COCl2.7H2O. So the number is not as important as the color change. Okay, so remember the color change for me. What is the starting color of cobalt 2 chloride? Blue. You might have used the test strip before, right? This is blue, but it's not lemon. It's cobalt 2 chloride flavor. It's blue. It will turn into pink, pink substance here. So this is pink. So you have blue to pink. And the other chemical which is used in a similar manner is anhydrous copper sulfate. So what color change should we expect this time? Oh well, a solid cannot be colorless. It should be white to blue. Okay, white to blue. Okay. A solution can be colorless, but the
it's dry, yes.
yeah, it should be white. A solid is seldom colorless. We rarely say that a solid is colorless. A solid is just like just white. So you have it turning into blue, copper 2 sulfate. Okay, so this is blue, and this on the left is white. So you have white to blue. Right. So note that these two tests are kind of limited. It will show you this result even with dirty water, with water in the drain. But does it mean that it's fit for drinking? No. So to test if water is pure, we have to look at the next test. Test for purity of water. So what do we use? Boiling. Yeah. So boil or melt the water. Yeah. Or you can say ice. If it is pure, what do you expect? It should have. Is it a sharp or range of melting and boiling point? Sharp. Okay. So remember the word sharp. It will boil at exactly 0 degree. At 100 degree, and it will melt exactly 0 degree. No higher, no lower. So that's what sharp means. Sharp, boiling, and melting point. But if it is impure, what will happen? It will show a range of boiling and melting point. Okay? For example, if you have impure water, let's say say water with some salt added to it, it may start boiling at 105 degree to 110 degree. Meaning it doesn't boil at an exact temperature anymore, but it boils over range. So the keyword here is range and sharp. That's the difference. Okay? So that's the test for water. Oh, and then we have the electrolysis, okay, of water, okay, and also the use of product. So when you electrolyze H2O, or I should say when you electrolyze brine solution, so recognize this word in exam. Brine means seawater, which means it is concentrated NaCl. So this means seawater, this means it's corn NaCl solution. And in a corn NaCl solution, there are 4 ions present. What are the 4 ions present in a corn NaCl solution? Na plus, Cl minus, H plus, OH minus. Yes, so you may want to write down Na plus and H plus, and then you have Cl minus and OH minus. Where does Na and Cl come from? Well, from salt, right? From the NaCl salt. And then we have water, H2O, dissociating reversibly into these 2 ions. So that's why I say there are 4 ions present in seawater. When you electrolyze it, well, we can also do electrolysis, okay, at the same time here. Which ion, which positive ion will be discharged preferentially first?
H plus.
H plus, because it is, lower in the reactivity series, okay, and so it will, get reacted first. So the equation that will happen to H plus is 2H plus plus 2E minus becomes hydrogen, which is a gas, right? Yes, okay. And because we have concentrated NaCl, that means we have a lot of chloride ion, right? So that means the chloride ion will be selectively discharged.
Why
So-
Na not? Why not Na? Na
Why not Na? Because Na is more reactive than H. Yeah, it has a tendency to undergo oxidation than it would to undergo reduction. So Na plus will not be discharged. You can assume that all the metal ion above hydrogen, it will not be discharged if there is hydrogen ion present. But then if I change the question into copper 2 chloride,
Yes.
this will become Cu2 plus. In that case, copper will be discharged.
Yes.
Do you understand this? Okay, so let me do this quick summary on the right. You should remember the order of reactivity. So it's KNaCaMgAl, carbon, zinc, iron, lead, hydrogen, copper, silver, gold. All metal ions above hydrogen, when hydrogen is present, they will not be discharged because they are all too reactive, more reactive than hydrogen. But then if you have a metal ion that is less reactive than hydrogen ion, present with hydrogen ion, these metal ions, they will be discharged instead. So that means in a solution of copper sulfate, you have Cu2 plus and SO2 minus, H plus and OH minus. And in a solution of salt, NaCl, Na plus, Cl minus, H plus, OH minus, which ion will be discharged? Which positive ion will be discharged in these 2 cases? So for the top one, yeah, H plus. For the bottom one, Cu2 plus. So do you see what it's happening?
Yes.
Okay, so H plus is the cut-off line. Okay, so right back to here. Can you tell me what's the equation for chloride ion discharge?
Cl 2E
2E minus. Okay, so what is the observation with chlorine gas being produced? Okay, what will you see when you have chlorine gas produced? What is the color of chlorine gas?
brown.
No, the brown one is bromine. It's yellow.
Yellow,
green.
oh.
Yellow is green.
Yellow.
Okay, so let me draw this diagram here. And can you tell me what does the longer rod represent? Positive. So can you tell me by opposite charges attract, which ion would move to the positive rod? Which ion would move to the negative rod?
Cl2 positive.
Yes. So the Cl minus, once they touch the rod, they will be converted into Cl2. And the H plus ion, once they touch the negatively charged rod by opposite charges attract, they become H2. And the observation here would be that you get yellowish green gas for chlorine, so you will see some yellowish green gas coming out. And for hydrogen, you will just see colorless gas bubbles. Okay? And can you tell me at the end of the electrolysis, what are the two ions that remain after the electrolysis reaction? NaOH. So this is why electrolysis produces a number of products, actually 3 products. Let me just draw out what are the ions that remain. Do you see that Na plus NaOH minus they did not react, right?
You can go home.
Na plus NaOH minus they did not react. So how many products can you get out of electrolysis of seawater? 3. 3. The first product is chlorine. So can you write down products of electrolysis? The product of NaCl electrolysis. Number 1, H2. So you find H2 here. Number 2, you have chlorine. So you find chlorine here. Number 3 is the
Sodium hydroxide.
yeah, don't forget that what is left can also be a product, right? You see, this is what is left. Yeah, you see the Cl and the Cl and the H they're gone. But that will leave behind Na and OH. So together, they become NaOH. So do you see, we have 3 different products, okay, from seawater. Right, and then, we have the line cycle. Yeah, you should also know the line cycle. So what's the connection? Yeah, so what's the connection between limestone, quicklime, slick lime, and lime water? You know, all these terms are very similar. What's the relation between quicklime, slick lime, lime water, and limestone?
All have carbon hydroxide.
All have calcium.
Oh,
Yeah.
calcium.
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 Calcium, yeah. So can you write down this formula here? CaCO3. When you heat it, it becomes CaO. When you add water to it, it becomes CaOH2. When you filter it, it will be clear CaOH2. And when you add carbon dioxide to it, you get back CaCO3. I want to put back the name to where they belong. This is limestone. Limestone has the same chemical with 2 other things, chalk
And
and marble, yes. Just know that these 3 things, they have the same chemical, calcium carbonate. Yeah. So marble means chalk means limestone. They are all calcium carbonate. When you heat it, it will give up the carbon dioxide. Okay? And they will then, the remainder will be CO. You can do subtraction. When you subtract CO2 from CaCO3, you get CO. Right? That's subtraction. Okay? Then you add water. By the way, CaO is called quicklime. And CaO2, we call it slick lime. Okay, so slick lime.
Is that lime slick?
Well,
Water?
there's nothing to do with lime. It's more
Lime
like,
water?
you know,
What's
it-
slick?
Select eating.
so
What is
it is
slick?
an alkaline substance.
Slick.
Okay, that I will put it simply.
Fine.
And why is there 2 different substances? Why are there 2 different substances with the same formula? Is there a typo here?
Dictionary.
Well, close enough. Okay, actually, calcium carbonate is solid. Calcium oxide is a solid. But you know, calcium hydroxide, is it very soluble or not very soluble in water? Not very soluble. This is why I wanted to put a star here. When you add water to calcium oxide, it will not convert into, a very soluble form of calcium hydroxide, which means you will get a clear portion of. So you know this is calcium oxide. This is a white powder, so CaO. There's only 1 layer here. When you add water to it, it will form 2 layers. The top layer is the soluble layer, CaOH2H2. The bottom layer is the insoluble layer, CaOH2 solid. You need to filter off the CaOH2 solid before you can get clear lime water. You know when you do tests on lime water, it's a solution that they give you, right? You don't see anything at the bottom, it's clear. That means we have filtered it, okay, to get lime water. And finally, how do we turn lime water back to limestone? Is to add carbon dioxide. So you see, this cycle has a mini cycle within a cycle. You see, this is a mini cycle. The CO2, after you release it from CaCO3, you can join line water to form calcium carbonate. So this is what we call a cycle. It comes in full circle. So the 4 equations that you must know, write them down. Here is the good news. You don't have to balance any of these. They are already balanced. Okay, so CaCO3 becomes CaO and CO2. So this is the equation. When you add water, CaO plus H2O will form CaOH2. Again, you don't have to balance it. And then, of course, for filtration, you don't need to balance it, okay, for sure. And finally, we have CaOH2 plus CO2 forms CaCO3 and H2O. Is that clear? The line cycle. Make sure you recognize these 4 terms. I know they are confusing, but they are different. You see, they're different. Okay, they're all different. Yeah, so you see limestone, chalk, and marble, they are like the same thing.
We took picture. Is that for a test?
What was it? This is just the official syllabus published by the Education Bureau.
Send it.
Yeah, I just want to.
Search.
Yeah. Yeah, you can look it up. Just type HKDSE CHAM syllabus.
Yeah.
The first page. The first page. Okay. Yeah. When I do revision, I like to look at this. Yeah. So that I understand everything. Okay. So now let's focus on. Are there other particular tasks that you guys want me to discuss?
What is
Enthalpy change.
anything included in the test? Just like
Oh,
revise all
everything
of
appears in the test.
Everything's in the
I made the test so that all topics appear.
Enthalpy change.
Enthalpy change.
Cycle.
Yeah, the
Enthalpy
enthalpy
change.
cycle.
Okay, so
Remember the lesson?
No, we really bad at that.
okay.
Don't bring
Well,
Ish.
Hess's law and enthalpy cycle. Yeah, so enthalpy change cycle. So first of all, there are 2 types of enthalpy change that you must know. One is delta Hc, the other is delta Hf. Okay? Yeah, so this physical sign here means it's standard. Yeah, means it's standard. Okay? So can you write down the full name? We'll only have to write the full name once. Standard enthalpy change of combustion. So let me teach you a method that you must be able to apply. Okay, very easy to understand. Okay, delta Hc. What does delta Hc mean? It is the delta H when 1 mole of a substance is burned. Okay, in excess oxygen. Well, you know different substances when they burn in oxygen, they form different products, right? When I burn carbon, what do I get?
Carbon dioxide.
Carbon dioxide. Okay, I know a lot of students would like to argue with me and say, wait a second, carbon monoxide can also form, right? When I burn carbon, do you see the word excess oxygen here? Yeah, so this is why every part of the definition is important. When we say that delta Hc is the delta H, when 1 mole of a substance burns in excess oxygen, we can eliminate like carbon monoxide. Carbon monoxide cannot form. Okay, when we do complete combustion, that is. Okay, so you can write down a few examples. When we burn carbon, when we burn hydrogen, when we burn propane, they will form different products depending on what they contain. So the way I like to look at it is, if you're burning something with carbon, they will form carbon dioxide. When you're burning something with water, with hydrogen, what do you think you get? H2O. You know, when you burn something, you get the oxide of those elements. So an oxide of carbon, carbon dioxide. An oxide of hydrogen, water, right, you see. Yeah. And finally, if you're burning hydrocarbon, you get both carbon dioxide and water. Okay? So there is not a 4th possibility. Usually in the exam, only these 3 possibilities, okay? But then do you notice another part of the definition? Do you see 1 over here? That means whatever it takes, you need to make this 1 in the exam. This number has to be 1 because by definition, delta Hc is what happens when you burn 1 mole of a substance. So for the second equation, something weird happens. To make this number 1, we'll have to do some like a sacrifice here. This will have to be 1/2. Because if you make this 1, how many OR do you see on the right?
1.
Only 1. So this is why you can only put 1/2 here, you see.
Yeah.
Yeah, we don't want to multiply this equation by 2 like you normally would. Because if you multiply this whole equation by 2, would this number still be 1?
No.
No. Okay, so now let's do some practice. Okay, I have a data bullet here that is not for DSE, but the values they are applicable. Okay, so let me go to this page in here. So we have some delta HF and some delta HC. Let me ask you a question here. I want to turn CO and H2 into CH3OH. And the question wants you to find this delta H. Okay, but then they are telling you something. They are telling you that 1 CO and 2 H2 will react to form 1 CH3OH. And here is what is given. You know that none of these you need to memorize. I mean the value. So let me show you the value. Okay, I'm just copying it straight from the data bullet. You don't have to remember any of these. So this is negative 283 kJ per mole. And H2 would be negative 286. And CH3OH is negative 726. Now, what do we need to do? Can you tell me when I burn carbon monoxide, what will be formed? So when we burn carbon, we get carbon dioxide. What happens when we burn carbon monoxide?
Carbony?
It will still form carbon dioxide. Okay, so anything with carbon in it, they will just be turned into carbon dioxide. So can you add one more equation here? When you burn carbon monoxide in oxygen, they will turn into also carbon dioxide. So how do you balance this equation to make sure that you always end up having 1 in here? 1 over 2 over 2, right?
Yep.
Right? Yeah, so if you leave this as 1, you will have 2O instead of, if you leave this as 1, you will have CO3 instead of CO2. Okay? So how do we do this? We will turn these into the combustion products. So CO will become CO2, right? Remember? Yeah, H2 will become H2O, right? What about CH3OH? When you burn it, they will also become CO2 and H2O, right? So now, you don't have to look at both sides. You just have to look at one side, okay? And I will look at the side with fewer reactants, fewer atoms. This side. How many CO2 do you think you can get out of CH3OH? 1. Because CH3OH has only how many carbon? 1. And you know to form each CO2, you need 1 carbon, right? So does it make sense that you only can get 1 CO2?
Yep.
Yes. Now, how many H's are there?
4.
To form each H2O, how many H do you need?
4.
1.
To form 1 H2O, how many
Two.
H? 2. So if forming 1 H2O needs 2 H, how many H2O can you get from 4 H's? 2. Makes sense, right? Yeah. And why did I say we will predict the products by looking at this side? This is because you know something called conservation of atom, right?
Yep.
If you have 1C, 4H, and 1O on the product side, that should also mean that on the reactant side you will still have 1C, 4H, and 2O.
Yep.
That means no matter which side you look at, you should get the same combustion product because of conservation of atoms. And now this is the easiest part. Okay, you'll find this extremely easy. Can you put the values back? For each CO2, you know per mole means per 1 mole. For each mole of CO burnt, there will be negative 283, like a delta H. Okay, so we will put negative 283 here. And that there is 1 of them. So you see there is 1 of them. So we times 1, or we don't times it by anything. What about H2? How many H2 are we dealing with? 2. But then according to the data, these values describe only 1 mole of H2. But you see 2 H2 here, right?
Yeah.
So therefore you multiply that by 2. So negative 286 by 2. You just take the relevant value and stick it in there. Trust me, this is the easier part, or the easiest part. Because later you will just turn it into a circle, you will see. What about CH3OH? How many we are dealing with? 1. So we'll do negative 726 times 1. Now, I want you to use your imagination. We are finding this delta H, right? Turn this triangle into a circle. Can you do that? So you have the delta H here. So this, depending on like the student, maybe you will find this very easy or maybe you'll find this very hard because it takes some abstract thinking. Can you see that? I'm turning this into a circle. Can you see that we can sort of mold this triangle into the circle here?
Yes.
Yes, okay, so everyone can see that. Now, can you tell me which arrow or arrows are pointing in the clockwise direction?
The black and the green.
The black and which green one?
One green.
The one on the right, yes. Okay, so you don't have to write this out in exam, but the way I remember is clockwise equals counterclockwise. Total clockwise equals total counterclockwise. So total clockwise equals total counterclockwise. I don't know how you learn this, but I know a lot of teachers ask students to, flip the direction of the arrow. Trust me, if you flip it,
The teacher tells us to.
you will screw up. Most of the time you screw up. If you don't screw up here, you screw it up somewhere else. Okay, so don't do this. For my method, you don't have to flip any arrow. Just check how many arrows are going in the clockwise direction. Add them all. And then check how many arrows are pointing in the counterclockwise direction. Add them all as well. They will become equal. Okay, so let's do this. It will always give you the correct answer. Trust me. Okay? I never get a wrong answer from this method. Okay, and I just so delta H plus negative 726 times 1 should be equal to all the counterclockwise term, and you are only doing addition. So this is why it's very hard to make mistake here if you are, adding things correctly on the calculator. You see, we only add up the clockwise arrows, and then we make it equal to the counterclockwise arrow. Can you type this onto your calculator? Tell me what is the purple delta H. Make sure you type the negative sign. Negative, okay, let me also verify that. Okay, so we have negative 286 times 2 minus 283 plus 2726. So do you all get negative 129?
Yes.
Yeah, so this is the how you find the delta H using delta HC. Okay, so is this method clear? It is kind of clean, okay, this method. So let me show you how we can do this for delta HF. Delta HF is very similar. So delta HF. This is the standard entropy change of formation, F for formation. So formation is defined in a different manner. So this is the delta H when one mole of a substance is formed from its elements. Okay, so it's formed from its elements. I'll give you a few examples here. Let's do C6H12O6 and H2 and like maybe C and C3H8. So can you tell me what are the elements needed to form C6H12O6? 6 carbon. And this is okay. And the second part is where 99% of it will give me the wrong answer. What is the element that forms? What are the other two elements that form glucose other than carbon? I will let you pick the equation. Will you pick the first one, or will you pick the second one? First or second? Second. Why not the first?
Because O is not standard in that form.
Does hydrogen exist as a single H?
No.
No, that's what element means. Element has to be stable. Okay, so can you put a big cross here? These two, they are unstable. Because they will form diatomic molecule, hydrogen and oxygen. But these ones, these are stable. So this is the equation. So with that being said, can you tell me what are the other equations for the delta HF of C, H2, and C3H8? So what is the delta HF of these elements? So the second and the third one is actually a trick question. What is the element needed to form H2? It's still H2, right? H2 is the element that forms H2. What about carbon? It's still carbon. What about C3H8? How many carbon? 3 carbon. And 4 H2. Don't write H here. Because H doesn't exist as H. They exist as here. H2, right? Yeah. So, and do you see something? This time it is this number that has to be 1. This number must be 1. Okay, so you may think that, no big deal, right? If that's 1, like why do we care? That's because when you look at this equation, let's see if I have this data here. I have C2H2. I want to react it with H2 to form C2H6. And this time the question is asking you to find the delta H here again. But of course they will give you something. They will tell you the delta HF of the following substances. So C2H2 and C2H6. So you don't have to memorize these values, like I said, they will give it to you. So you have this here. C2H6 has delta HF of -84. So this is -84. C2H2 has delta HF of positive 228. So can you tell me why did I not give you the delta HF of hydrogen? Yeah. Do you notice that whenever we find the delta HF of element, are there any changes involved when we write the delta HF of any element? No. If we do this for hydrogen, I can do this all day. The delta HF of oxygen will be O2 becoming O2. The delta HF of carbon will be carbon becoming carbon. For any element, the delta HF will be the same thing becoming that substance, right? So that means there is no change involved for elements. Okay, maybe let me put it more simply. What is this? This is a compound, right?
Yes.
These two are compounds in rectangles. What about these? These are elements. Okay? So these are elements. So these are elements. Can you see that with compound? The equation actually has different thing on both sides, right? With compound. But what about with element? What do you see on both sides whenever you write delta HC for delta HF for element? Well, there is something. There is the same thing, right? Yeah. That means are there changes involved? No. If there are no changes involved, that means the delta HF of element is 0, because they did not change. But the delta HF of any compound will be non-zero. So I can show you this table. You can see all the compounds here. These are all compounds. And none of them have the 0 value, you see. Okay? Yeah, so the takeaway here is that, write this down. The delta HF of all elements must be 0. And the delta HF of compound must be non-zero. Okay, and now this is the most important part. Can you tell me what are the elements needed to form C2H6?
Carbon.
How many carbon?
2 carbon.
2 carbon. And
3 hydrogen.
3 hydrogen, yes. Okay, and do you notice that I draw the delta HC arrow pointing away from the substance? These 3 green arrows represent delta HC. They must point away from the substance described. But when you show the delta HF, what is happening to the arrow? They are pointing towards. This should make sense to you, because when you form something, the arrow should point towards these things, right? You're forming these things from the element. But then when you are, what about in here? What about in here? Why should we point the delta HC arrow away from the substance? Because when you burn something, they become something else, right? So the arrow shows you that when you burn this substance, it becomes these things. And this arrow here shows you that to form the substance, you need these elements.
Yes.
Does it make sense? The direction in which you point the arrow is not random. Okay? Maybe you can put down a short note here, okay, explaining why the arrow points the way they are pointing right now. So right now, all delta HC arrows point away from the substance described. And in here, all delta HF arrows point towards the substance. So you see one is pointing towards, one is pointing away. And once this is done, okay, you can very quickly find the answer. Okay, let me just do this here. How many C2H2 are you forming here? 1. So, and you know these are kilojoule per mole, right? Per 1 mole, right? So therefore, what should we write on top of this arrow? We should do plus 228 times 1. because there's only one C2H2. What about H2? This is actually 0, right? You know, the hydrogen here, okay, should have delta H equal 0. So, and then if you have 2 hydrogen here, it will be 0 times 2. Yeah, of course you can just not write out the 2, but you should know if you have a number that is not 1, you need to multiply it by that mole ratio. What about in here?
1.
What do you do?
Negative 84.
Times 1. Yes, negative 84 times 1. Okay, I recommend that you still put down times 1. It won't take you more than 1 second to write times 1. And now, let's do our trick. Can you morph this into a circle? This time you do this. Yeah, because I can't keep doing this for you. Okay, I want to know, okay, if you are able to morph this into a circle. Or you can also treat this as a triangle, and you ask yourself which arrow. So if you see a triangular path in here, which arrow or arrows are pointing in the clockwise direction? How many arrows are pointing in the clockwise direction?
2.
So some say 2. Do you see that these two are in the clockwise direction?
Yeah.
Together with this one. So this is why if I want to turn it into a circle to see it even more clearly. Let's do this now. So we have,
Don't be.
they are 3. They are 3 arrows. Together with the unknown, that makes 3. So you have, can you see that these 2 arrows are these 2? Yeah, they are pointing in the clockwise direction, you're right. But I think you might have missed this one. Do you see that this is also pointing in the clockwise direction? Yes. And you have this one. Okay, so can you put back the values and use the trick I taught you? Total clockwise equals total counterclockwise. Okay, so these arrows are pointing all in the clockwise direction. And this one is pointing in the counterclockwise direction. So therefore, can you sum it up for me? So you have 2, 2, 8. And remember, you're doing only addition. You don't have to do any subtraction. So 2, 2, 8 times 1 plus 0 times 2, okay, is equal to negative 84 times 1. Okay, oh, and I almost forgot the delta H. Okay, the purple delta H. So the purple delta H here plus this. So can you solve for the purple delta H? Yes, okay, and don't forget the unit. Kilojoule, yeah, per mole. Yeah, why are these answers in kilojoule per mole? That's because you are calculating the delta H from something with the unit kilojoule per mole, right? So does this method make sense to you? Does this method make sense?
So we have another method besides cycle?
Uh,
Circle?
Is this
Like in a
method
straight
to?
line, you form the whole bunch of like reaction and you just like directly count of that.
Oh, you mean when they give you some equations?
Yes.
Yes. Okay.
Is that
So.
that much more easier than this?
Well, I would say both of these methods they will probably appear in exam. Okay, so let me show you one such example. So we have I have some. Yeah, I know this is not for DSE, but it will be relevant. So here we have. Oh, do you mean these? It's where they give you equations like these, and then they expect you to find the.
Yeah. Don't need to like.
Well, yeah, I would just say for this method, if you know how to use simultaneous equation, you will know how to do this. Simultaneous integration. So let me explain. So take a look at this question here first. Okay, so we have C. So we have CO2. So we have so this one here. Oh, I don't know where. Okay, anyway, so can I just copy this over here? Okay. Okay, done. Okay, so we have C. Can you see that we have C plus H2, 2H2 forming CH4? We want to find this delta H. We want to know what this is. Okay, so first, you need to compare the equations that are given with the one that is being asked. Can you find something that is common to both these equations on top and this equation? Which substance you see in this equation can only be found in one of the equations on top?
C.
C. So you locate it. So C, we locate it. And by locating it, we mean we need to check its position, whether it is appearing as a reactant, like in this equation, or does it show it as a product. If it is already on the equation side, you don't need to fix the direction of the equation.
Yeah, yeah.
And you have to also check the mole ratio. What is the mole ratio here?
1.
1. And the mole ratio here is still 1. That means you can keep it. You don't have to do anything to it. I will explain to you why we have to sometimes change it. Now, can you look at the second thing that is common to this equation and one of the equation on top? H2. Now, what do you notice? The mole ratio, are they the same?
No.
No. So to adapt this equation onto this equation, you need to fix it by fixing the mole ratio. So how do you fix the mole ratio? Times 2, yes. And then finally, can you find a third substance that is common? CH4. Oh, I ran out of idea for shape, so I'll use a cloud here. Can you see that we have one CH4 here?
Yeah.
There's also one. Seems like we don't have to do anything about the mole ratio, which is true. But do you see that it appears on the wrong side?
Yeah.
So to fix that, we need to flip it. To flip equation, we multiply by
Negative 1.
negative 1. So can you do this? And right now, what happens? So we have C. When I say we keep it, we mean we just keep everything. We just copy it. Okay. When we multiply equation by 2, not only does the delta H gets multiplied, the mole ratio also gets multiplied. So we have 2H2 plus O2 forms 2H2O, you see? So the delta H is negative 512. I already, negative 572. I already multiplied this by 2. Okay, this is negative 572.
Yeah.
What about the last one? Can you tell me what happens when I flip it? What should I write?
CO2 plus 2H2O.
Becomes,
CH4 plus 2O.
yeah, and when you multiply this by negative 1, don't forget to do this to the delta H. So we have positive 890 now. And this is the fun part. You just add them up. Just add them up. Tell me what would cancel out. Things on the two sides, CO2 will cancel out. What else? H2O will cancel out. Are there any things? 2O2. You know these two and these two, they cancel out, right? What remains?
CH2 and
Gives
This one is much more
CH4.
fun.
Do you see that this is exactly what they are asking you?
Yeah.
Yes, and let me tell you, the delta H you get from here, this plus this plus this, will be equal to the unknown delta H.
Oh, that makes sense.
Yeah, and this should be how you learn it, okay? Now, to check that you, to check that you really understand what is happening, you know all these are just annoying examples to confuse you, okay? I can also send you this package, even though it's not like aiming for DSE, but it will be relevant, and I've hidden
What
the
about
answer
the
here.
more challenging one? They don't give you the whole bunch of equations. You have to find by yourself.
Yes,
They just
okay.
give you the
Like-
entire thing.
Let maybe this one. Okay, let maybe this one.
I want that one.
Okay, so you have hydrazine, which you don't need to know what it is. Okay, they are telling you that it's N2H4. Okay, so it reacts with oxygen according to this equation, and you know that the delta H is negative 623. So what is the standard enthalpy change of formation of N2H4? Can you write me an equation? How do you form N2H4? What are the elements needed to form N2H4?
Hydrogen.
Yeah, what do you write?
N2 plus 2H2.
Yes, N2 plus 2H2. Don't forget that formation means you're forming one mole of something, okay? And what are they telling you? They're telling you the standard enthalpy of formation of water. So can you turn this also into an equation? What is the standard enthalpy change of formation of water? What are the elements?
H2 plus
H2 plus
2O2.
O2 plus
1 over 2O2.
1 over 2 O2, right, okay? So make sure when you form something, this must be 1. Yeah, when you form, because that's what kilojoule per mole means. Kilojoule per mole means you're forming 1 mole of the substance. So what is the value here? This is negative 2H6, and they are asking you to find this. But then they are telling you another equation. So can you link one of these equations to this first one here? So can you see that? Let me just copy this one from on top. N2H4 plus O2 forms N2 plus 2H2O. Do you see H2O in here? H2O in there. How many H2O are you forming?
Two
2. So therefore we can put this
times
equation here.
times two.
Yes, times 2. So we will write delta H equals negative 286 times 2. Times 2 because there are 2 H2O here, right? Yes? Okay, so can you tell me if I multiply this equation by 2, what are the elements that I should put in here? 2H2 and
Plus
O2. So we'll have 2H2 and O2 together with an unused N2. Yeah, so these N2, I still need to put N2 in here because while these two, they will form H2O, the N2 will form the N2 instead, right? Yeah, but does the N2 have any value for delta HF?
No.
Why not?
It's an element.
It's an element, yes. So this is why you see I have to put N2 here. If you do not put N2 here, the equation is nonsense. Because how can you form N2 and 2H2 with just 2H2 and O2? You need also N2. The N2 is put here to make sure that the number of atoms are equal. In here, and in here. The N2 is to make sure of that, okay? It's to make sure of that. So now we are not done. What about this? How do you tie N2 and H2 to N2H4? How do we put this green equation here? Which direction should it point?
N2 to N2H4.
You mean N2 plus 2H2
Yeah.
becoming,
Yes.
yeah. So we will put this equation here. And now use this method, okay? So you have the delta H equals unknown, yeah, plus negative 2A2 times 2, and then you have, what is this value on top? So what is this value, what is this equation?
Negative 6.
negative 6 to
Yes, now turn this into a circle. Show me which arrow are pointing in the clockwise direction, which are pointing in the counterclockwise. So how many arrows in here are pointing in the clockwise direction?
two.
2, which 2?
The
Green and-
black.
Red, black.
Oh, you mean orange?
Yeah.
Yeah, or orange, yeah, or maybe this black, okay, yes. So therefore we have the orange one, yes. We will all agree that this is pointing in the clockwise direction, right? And then we have the green one. This is the unknown one, but it's okay, we'll find it soon enough, okay? So we have the unknown here. And finally, we have the blue one, which is negative 2A6 times 2. Can you use the rule I taught you, okay? Clockwise equals counterclockwise. Tell me what plus what equals what? So clockwise equals counterclockwise. So we have delta H plus negative 623 equals, so what is the answer?
51.
Yes, okay, or 623 minus 2A6 times 2. So, therefore, because this is an MC only paper for another example, so therefore they don't really expect you to calculate it, but you can see that the answer will be this one. So it will be 623 minus 572. Okay?
What about non-cycle? The
Non-
equation.
Oh, what do you mean non-cycle?
The bundle of equation.
I think that
The-
one is useless.
No.
Is, you mean this one?
Yeah, if we do like that, how can we do like that? Like if not uses cycle. From the previous.
So there are only two methods. One method is to construct the cycle yourself.
Yeah.
The other method is to compare the equations and adapt the equation so that they would add up to give you the equation you want.
Yeah. How can we do like the second like that in the below one?
You mean use this method
Yeah.
here? Yes. Well, you can. How should I put it? Okay. Okay. So if you really must solve this question here using the top method, you first have to write out the equation like we did. So we have N2H4 plus O2 gives N2 and 2H2O, right? So we write out this equation.
Yep.
This has a delta H of negative 623, right?
Yep.
And then we write out the other equations that we know. Okay, so let's do this. We know this green equation. Well, we don't know this green equation, sorry. So N2 plus 2H2 forms N2H4. So this we want to know. So this is an unknown at this point. And then we know another equation, which is H2 plus half an O2 becomes H2O, right?
Yep.
So this one has a value of, you see, is given, negative 286. So again, just like in the previous example, when you have one unknown equation and multiple unknown equations, you find stuff that are common to this unknown and the top two known equations. Do this. What do you find in this green equation that is only found in one of the equations on top?
And two.
And two, can you check the position and the mole ratio? Which needs to fix? Need to be
The
fixed.
sign.
The direction, right? So how do you fix that? Times the first one by negative 1. So let's write out what we have after we multiply the first equation by negative 1. We have N2 plus 2H2O becomes N2H4 plus O2, right? When you multiply this by negative 1, the delta H will become
623.
positive 623, yes. Now, we are half done. What about another substance that you need to the green equation and the blue equation? H2, okay, remember unique. We don't look at H2 because they are found in both equations. Yeah, okay, we don't look at O2 because O2 is found in both equations. But H2 is uniquely found in the blue one, not in the orange one, right? Yeah, so can you check the location? Is it in the correct side?
Yeah.
Yes.
Yes, but what needs fixing? The mole ratio. You see the given one has 1 in it, but the one we want to find has 2. What do we do? Times 2. So can you change the blue equation into the new one now? 2H2. When you multiply this whole equation by 2, what do you get? 2H2 plus O2 becomes 2H2O. And when you multiply the equation by 2, you should also multiply the delta H by 2. Which means the delta H will now be negative 572, right? Now, can you add these two equations up? What do you cancel out? Oxygen and 2H2O, okay? And can you tell me what do you have left? You have N2 forms. Yes, what is the answer here? It will still be 623 minus 572, right? You see? So that means, yeah, I like your question. We can solve problems in many different ways, depending on your liking. Do you like this method more?
Yeah, I like that. No,
Okay,
I
maybe
like
of course you do.
I like.
Okay,
the-
yeah, I understand. Most of them would like to use the equation approach more, but this is more visual, you see. Yeah, so just take the side you like, okay? And so any questions so far?
No.
No, okay. So I hope that you can all try this question here. Don't worry, I have hidden the answer here. And I'm giving you the answer because I trust you, because I know you will. What's the point of looking at the answer if you're preparing for the mock exam? So this is why from this point on, I'll only give you questions with answer. So you can quickly check the answers, okay? And I know this does not target DSC, but this is also very good practice that you should try, okay? So, any questions?
No.
And remember tomorrow the test will last till 4.
Do you have
Last till 4.
Yeah.
Yes.
Titration and retitration.
Oh, but okay, titration. So for that, I can answer you like tomorrow. Yeah, because I have
You have
some
to do.
other like stuff too, like
Yeah.
yeah. So and we can look at it tomorrow.
Sure.
Okay. Yeah, but tomorrow we have. Yeah, make sure you come
2.5
here on
hour
time.
test.
It's not a test, it's a pre-form. It's for predicting your grade.
But it still count GP. What do you mean?
Yeah,
It's
so,
a-
It's okay.
yes, so this is why you should all come here on time. Okay? Yeah, it will start sharply when the bell rings after lunch.
Oh.
And I'll collect the paper at 4, by 4. So you have the full 2.5 hours.
Okay.
Okay? So please come here on time. Okay? Right. Yeah, and then through checking your response in the test, I know how well you do in different topics. But I hope I have cleared this very important concept first.
Yes.
Okay? And you can try these questions here to consolidate your understanding. Okay?
Yes.
Right. So
Still with you long.
yeah, make sure tomorrow's mock, then we will move on to industrial chem.
Sir,
Okay?
is it possible for us to finish all our chapters with you, or is it not possible?
I will just try to cover as many as possible. I don't think it's possible to cover everything. Yeah, so not everything, but yeah, I'll try to finish as many as possible. Okay? Yeah, so can you try this in here? And right, just a moment. Yeah, so these are exercise on like a Hess law. So Hess's law.
So we upload the notes also.
Yeah. So I'll upload the notes as well here. So make sure you review these 2 pages. Pay attention to which direction does the arrow point. Okay. Or if you're more comfortable with the equation method, you can use the equation method. Okay. Right. So I can tell you that the more exam, the pre-mock will be testing you on all topics. There's no mistake. Okay. Other than the topics we haven't discussed yet, I have selected the question. You won't see questions that you don't know how to answer. I'm only giving you, well, I hope you can answer them, but they are certainly the things you have learned. Okay? Yeah, so,
I feel like my level is like 2 or 3. Yeah. It's
Okay.
very down before.
I know a lot of exams going on right now, but yeah, so try to do more revision over the week's end.
So teachers after you.
Oh my god.
Page 5,
I feel you.
What's that?
This is
Oh, I don't care about that. I don't need to care about that.
2016
What is that?
DSE.
I don't care.
Organic chem.
So today is 24th
No, it's so.
of October.